Hey, happy Sunday. This is PFG Live, the podcast that asks how many more tools can we fit in such little space? Welcome aboard. We have a great crowd. It is presently 65 degrees Fahrenheit, 51% relative humidity in the southern New Hampshire. My name is Spencer Webb, and if you think you're in the wrong place, you're in the right place. So welcome aboard to everybody in the Discord. Tucker is here. Josh is here. Dale, Carl, AJF, Daniel F., and Robin Renzetti. Welcome aboard. Let's see. From CJ Stevens in East Tennessee, 78 degrees and sunny. Hello. I hope you guys are drying out. Carl Tauber is here, 56 degrees Fahrenheit and cloudy in the People's Republic of Rhode Island. And in the Discord chat, we have a lot of people. Let's see, who gave the first weather report? Dale is reporting 15 degrees science, 45% relative humidity in Edmonton, Alberta, Canuckistan. Josh is checking our audio, and he reports, check. Tuck in the Buffalo, New York, reports 76 Fahrenheit and feels chilly, and it's sunny. Wow, 76 over there. That's amazing. In southern Manitoba, Josh is reporting from a local weather station. Winds are 310 at 11, gusting 18 knots. Temperature 10, dew point -00. That's what happens when you get an automated report from a computer. The remarks are peak wind, 310 at 19 at 1612. Okay, we'll take 19 knots. Michael Juan has joined us in Discord. Welcome aboard, sir. Well, I guess to make it complete, Manchester Airport is currently reporting winds are 230 at 4 knots, visibility 10 miles, few clouds at 3,500, broken 25,000, temperature 19er, dew point 05, altimeter 3006. And the remarks are mere piffle. So we took last week off. This was a good thing. Many projects going on right now. Delivered some serious grinding that I talked about. We did some grinding on magnets of various sizes. In fact, in the thumbnail for today's show is a picture of a SLA printed collet, which I used in that job. And it's sort of, part of what we're going to talk about today. So in the world of PFG Stones, we got everything shipped out. We successfully excoriated Global Post from our system. It's gone, and it will no longer darken our doorsteps. Oscar is with us. He says, "What's up? It's around 10 degrees science in Finland. You should put your sweater on, dude." But welcome, Oscar. Nice to see you. What else is happening? Happy New Year to those that celebrate. We were at my mom's last night and had a lot of food, and it was seriously yummy. We are going to cover a couple of topics today, and we're going to take them in the reverse order that they appeared on your screen. But, there's Robin. Hi, Robin. If you have any questions, please pop them into chat. We will take them asynchronously. You could do that on Discord. You could do that on YouTube, and we'll be happy to answer any questions. And yes, I gave it away. Robin is going to be part of our show today. So first things first is we've been fighting the good fight on dry filament for our 3D printing. And I know it sounds like we're beating a dead horse, but the reality is that lots of problems go away when our filament's dry. And the guys that do injection molding, they have whole machines that take the pellets and dry the pellets prior to injection molding. So the industry knows, and I think we, meaning 3D printing heads, are starting to figure that out. But we had a problem. with our recent epiphany, in which we looked at the containers that we were drying things in, and we suddenly realized that everything is a screen door on a submarine. I'm looking for the picture, and you're seeing all my pictures from yesterday. Let's see. We have a setup. There it is. We started a long-term test, and in this long-term test, we are testing multiple containers for protecting filament from humidity. So theoretically, you get a roll of filament, you put it into your filament drying oven, and you bake it for whatever your prescribed time is. I don't have my chart in front of me, but I believe I use 120 degrees Fahrenheit for PLA and 150 degrees Fahrenheit for PETG, and other filaments have different recommended numbers. Those numbers, by the way, are approximately 20 degrees Fahrenheit below the glass transition temperature for the material. They're not coming out of nowhere. So we're testing, after your filament is dry and you want to store it, what do you put it in? So you may notice that in the picture here, one of our suspects was a Sterilite container, which I discovered. I liked it a lot. I bought, I don't know, I must have a dozen of them, if not 20. And it nicely holds one roll of filament. It nicely holds one cylinder of desiccant. And we thought we were like styling. Well, it was an endless chase. The filament therein would still get moist. We'd change out the desiccant. We'd have to keep up on it, and it was a lot of effort. And effort is money. And so we started looking at things a little harder. So in the research, I discovered, we talked about in the last PFG.Live, this paper on water vapor permeation in plastics, which was done by the Pacific Northwest National Laboratory, a former client. And it turns out that the plastic containers we were using for storing filaments were screen doors on a submarine. And now we had numbers. So we started looking for other solutions. The pictured here is the current experiment, which is actually, we're actually growing it literally even today. So starting from the left is a 5-gallon metal pail with a lid and a rim clamp. There's a fancy name for that. I don't remember. The next one to the right is our favorite Sterilite container. The next one to the right are these aluminized mylar bags that I discovered are intended for food storage. So that one happens to be a 2.5-gallon bag. They have them in 5-gallon bags, and they look pretty cool. Interesting note, the Sterilite container is, I'm going by memory, I want to say $6 or $7. That bag, that aluminized mylar bag, is a $1.70, $1.50. It's very inexpensive, and it has a lot of promise. I started noticing the consumer products that are powders that are delivered in those bags, and I said, oh, okay, the industry knows, right? And then finally, the fourth thing in the photo that is up on your screen is nothing. It's a Sterilite container with no lid, and the desiccant is pitched in there. Now, the desiccant we're using is these desiccant packs, which I've literally had for, well, since 2009 when I got my vertical machining center. It was packed. Well, actually, those, I can't be sure if those were in the vertical machining center or if those may have been in the grinder, but I have like a dozen of them, and they're about the size of your fist, and they have a little loop to hang it on something. Well, all of them went into the oven. All of them dried for 16 hours. They were dry, 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 dry. And a pair of those is in each of these containers. And I measured the weight of the desiccants to 1/10 of a gram. Now, one of our guys on the Discord server wasn't sure that we're going to see anything. Okay. So I did a little cheat today, in fact, and I'm going to, let's see if I can get there from here. I will show you the measurement that I made today. Here it is. So the no container pair of bags was measured at 356.8 grams on my triple beam balance. The original 3 days ago, when we started the experiment, it was 342 grams. So that picked up 14 grams of humidity in 3 days. That's with no container. So we're going. I'm very excited about seeing these results. Now, the other thing that I added to the list was a standard 30 caliber ammo container. You know, it won't fit a spool of filament, but we were very curious about it. And I was using it to store these dry desiccant packs. So I wanted to know how it behaved. That's underway. I don't have that data. And then my good friend Doug, who a fellow nerd, he's bringing over later today 2 more things that we're going to set up for the same experiment. The plan is that we run this for about a week to 10 days, and then we open everything up, measure all the desiccant packs, record the data, everything goes back into their containers, get sealed up again, and we continue. So it's going to be a long-term test, and we'll see how that goes. Carl, let's see. Carl had a question. Carl, did you want to? Your audio is live.
Yeah, a couple of comments. First of all, silica gel is a good desiccant, and I think it's used because it doesn't create dust. But it has and it's non-toxic, but it has relatively modest capacity. So you want to be in a container that has very low moisture permeability, and all plastics are bad. How bad? Polyethylene is the worst. There are others.
Polyethylene is the worst. Wait a minute, Carl. My Sterilite containers are proudly made out of polyethylene. Are you telling me?
Right, and they leak like sieves. the advantage to the Sterilites is they're thick, as opposed to a plastic bag.
Thick-ish. Yeah, excellent. Good point.
The other comment is the only things, and I've had some background in this dealing with polymers, that the only things that reliably keep out moisture and oxygen are either metal or glass. And that's why the metallized polyester is used. And if you've seen modern helium balloons use that as well, because they don't leak as much.
Well, this was all.
It's not perfect because of the fact that the aluminized film always has pinholes in it. The production process can't prevent that. So there is some loss of or ingress or egress of moisture.
So this all started when I was taking Jared to the high school, and we saw a mailbox with a helium balloon, aluminized mylar balloon on it. And I kind of noted it, and we dropped them off. Next day, I load up Jared. We head off to the high school, past the same mailbox. Balloon is still there. Drop off Jared. Next day, we're driving down the road. I see the same thing. I look over, still there. I'm like, okay, hang on. And that's when I started looking for these aluminized mylar bags. So we're hopeful.
Another option that you might want to consider is steel paint cans. which I believe are relatively inexpensive.
Yeah, I'm hoping that these 5-gallon pails are in the same genre and they are the answer. We'll see. We'll see what happens. But I appreciate the info, and I also heard about the imperfection of the aluminized mylar, but I think it'll be so many orders of magnitude. I predict, hypothesis, that it's going to be so many orders of magnitude better than our favorite Sterilite that it won't matter. Thank you, sir. I'm going to send you back to the finger sandwiches now. Okay. So, yeah, excellent point. By the way, Carl is dead on. This paper also says metal and glass. Have a nice day. So that was something. So the experiment continues. We will report the pail. The pail with the lid is I'm gonna pick on you for that in a second. The pail with the lid can be had for $20 to $30 with the lid and everything. And like I said, those bags are $2. Now, Robin, what is water glass?
I don't know exactly what it is without Googling it, but water glass is a way of treating like an egg. You can dip an egg in water glass. It's some kind of silicate or something, I think. But evidently it seals up the porosity of an egg enough for them to last, I think, indefinitely.
Wow.
So, yeah, obviously it's not a solution to this problem, but just an interesting thought.
Okay. We have homework. We'll check it out. Thank you, sir. Awesome. I didn't ever hear that. So the goal is to find a cost-effective container. Now, my friend Doug took or essentially made a glass container out of an aluminum structure with glass panels, and he used HVAC tape, the metal tape. And in fact, I sent this. You remember when I sent you this picture, Robin? Doug casually sent me a picture of his filament housing and his hygrometer, the one we trust, the Sensorion, and it said, was it 2 or 3%? I think it was 2 point something percent relative humidity, and we're both like, "Holy cow!" Well, it was glass. So that was part of the deal. Anyway, more data to follow. So what we're going to do is a week from today, we will report the numbers, and then every week thereafter, as we're able to, we'll report the numbers, we'll plot the data. There's some corrections to the data, which include the volume of the container, right? So if I start the test in a 5-gallon container at 66% relative humidity, and I start the test in a 1-gallon container in the same room, then clearly one of the containers has more moisture in it to begin the test. So we're going to pull that error out. My friend Doug already calculated some of this, and we'll see what it says. We'll have data. We don't have to imagine, but we will be doing it in a cost-effective manner that isn't ridiculous. We looked at there are cabinets for semiconductor materials that have self-regenerating dryers, and that's all great. Who wants to spend $5,000 to store 10 rolls of filament? I don't think anybody does. So that's where we're heading. So that's the report on dry filament. It's been pretty exciting. I've had this thing running in my head now for weeks, and we finally got a chance to launch it, and we will let everybody know. Once again, if you have questions, there's a question from Greenwood AG. Do you think there is any advantage to vacuum packing in Mylar with desiccant as opposed to simple desiccant without vacuum packing? So here's what we learned. First of all, the vacuum packing is probably doing nothing. There's a little bit of Carl's got a good answer. There's a little bit of moisture in the pouch, no matter what you do, but it's not significant. We're trying to stop the ingress. So really, it's about the material. And Mylar itself, we don't have data on, and we don't have a prediction on. But aluminized Mylar, stay tuned. Carl says it's probably counterproductive, meaning the vacuum packing, because you're adding a pressure gradient to the concentration gradient. Some of the data that Doug is currently collecting indicates that a factory fresh, vacuum packed, with desiccant roll of filament from bamboo sitting on the shelf absorbs moisture and does not indicate any loss of the vacuum. You still, the bag is tight. It still, hisses when you put your knife in it, and it absorbs moisture. And we have data. This is not like maybe, where we have measurements, which is pretty amazing. Robin posted the sodium silicate information. Interesting. We'll have to talk to some of our chemists. So I'm going to wrap the topic because I think, I just wanted to let everybody know that the experiment is underway in a secret underground bunker right next to my 3D printers. And we'll report more. So some number of weeks ago, we had the esteemed Tom Lipton and Robin Renzetti on, and we talked about the title of that agglomeration was Two Guys and a Pencil. And after that episode, we had this little text chat, and the idea came up of, hey, why don't we give these guys a problem to solve that they have no knowledge before the episode, and we all get to watch them solve the problem in real time. And I thought this was a super idea because I think it's really instructive to see how somebody thinks who is an expert in an area. And
I am not an expert.
Sorry. Somebody who's an expert in an area going through the problem and, reasoning it out. Somebody like Tom Lipton.
That's a bozo mistake waiting to happen there.
And, who's done lots of very physics-related, crazy machining problems to solve. So we're going to talk a little bit about that, and I'm going to bring back the esteemed Robin Renzetti. Robin, hello.
Hello.
So this was a cool idea. I don't even remember who had the idea, but we're very excited about this. So I have created a problem definition, which to put out to everybody, which basically says we're looking for something that would be a problem the size of a milk crate that uses tools that we know are in our various shops and needs some careful engineering to solve. Essentially, that was the requirements. Does that sound reasonable to you?
Yeah. My one suggestion would be for people to think. It almost sounds like wimping out here on my part. At least Tom can speak for himself. But think more of what would be the most educational in the time span which we have, versus trying to stump the engineers.
Totally agree. I think that's the spirit.
Yeah.
That's the spirit of it. But what we're going to do is we're going to solicit ideas from everybody, and hopefully a pile of them, right? And then we're going to, now we meaning me and my local cohorts, are going to look through them and say, oh, that's a good one. Yeah, that's not such a good one. That's a great one. And we're going to rank them. And then we're going to pick the one, okay? And you and Tom will have no knowledge of this. And then we're going to bring you guys in and lay it on you and watch you work.
It'll be fun.
It'll be a lot of fun. A couple more people just checked in. Court Langkemper Welcome from Amsterdam, Netherlands. PA1CSL. Nice to meet you. 12 degrees science, 53 degrees Fahrenheit, overcast, relative humidity 78%, winds east-southeast at 8 knots. QNH, I like you already, 1,002 hectopascals. And that's as accurate as we can stand to get. Awesome. So what I've done, I don't know if I could show you this. If you go to pfg.gg/links, okay, and you scroll down, let's see if I could get this going here. This is not exactly, no, it's not going to do it. Oh, we're on the wrong screen. That's why. Here we go. There we go. You'll see something like this. This big button that says submit your problem. I just want to remind you that this is a problem related to what we're talking about, not every problem. So if you want to submit your idea, I mean, we could have overload here. If you want to submit your idea and you hit that button, you go to, let's see, I can't show you completely, but yeah, you go to a Google Forms page, and it will let you fill out the form in which you will be able to present your problem for solution. And that's live right now, and you could spread the word. I will post this on the usual channels, and I will start collecting that data. But that sounds like a lot of fun, and I'm looking forward to it. So when you let me just get back to my so we're calling that the problem process. And when you get a problem, a brand new problem that lands on your desk, Robin, what is the first thing you do?
Most of my later problem-solving things almost all relates to grinding apparatus. A vast majority of my work was taking existing diamond dresser spindles made by other manufacturers that customers weren't happy with, looking at what was there and redesigning a more bulletproof version, and then making them. Early on, way back, even during my apprenticeship, I worked with an engineer from Pepperidge Farms where we were building crazy stuff. Like one of the projects was making a machine to sandwich Milano cookies, replacing the ladies who did that, which we never got all the way through it, but we made a valiant attempt. I think they're doing it with robots now.
I'm a proud supporter, by the way.
We did make things like they used to manually fold turnovers at Pepperidge Farms, where there's a layer of puff paste distributed onto a conveyor belt, where there were four strips across. It was actually one sheet, but then it was cut with a rotary knife into squares, and then it would get filling deposited in the middle of it, and then ladies would manually grab a corner, fold it corner to corner, press it down enough before it went into a die that actually crimped the edges. Well, we did build a machine that took the manual fingers, go down, synchronize with the belt, grab the corners of the dough, fold it over, press it down before it went, and followed it, and then came back and went and did the next one. So it's just, look at the problem, having some experience with previous things. That's really the biggie. It's just a lot of experience with mechanisms, and so you've got a vast library of things that roll around in your head on ways to approach things.
Did you ever
I don't have any special magic.
Did you ever have a problem get plopped on your desk, and you read it, you looked through it, you understood it, and then you said to your potential client, you know what? I'm not your guy. I'm the wrong guy for this problem.
Yes, I have said things where I don't think my area of expertise is going to be the most beneficial to you. I don't have much to add here that's going. I think it's going to add any value because it's in a realm that I'm just not familiar with, and there's got to be people better suited than me to attack the problem.
And I have to agree with you. I've had the same thing, and had to say, yeah, I'm the wrong guy for this particular thing. And I think clients like that. I think it's a good thing, and I think a client respects you for that. And one of the things as a young consultant or a young contractor is you don't want to say no because it's a job. But I think as you get older and grayer, saying no is a skill that's pretty super important.
Yeah. They're going to find out anyhow. So just cut to the chase and just, fess up and say, hey,
Yeah.
put your pride aside and say, you know what, I'm not the guy for this. Sure, I could slog along and take 3 times as much money to do it, but, why would you do that to yourself?
Did you ever have a situation where a client said to you, I know this is not your field of expertise, but I still want you on this project because of the way you think?
Yes. I can't reveal who it is because of a non-disclosure agreement.
That means it's a good one.
but I said I don't really want to do it because I'm not set up equipment wise or whatever, and they said they still wanted me to, and I should have never never backed down because I did, and then ended up saying, you know what, sorry, but I'm still no. The answer's still no, even after I said yes.
Yeah, and that's I joke about it, but here it is sitting on my monitor to remind me, right?
Yeah.
A 3x5 card that just says no.
Yeah, follow your gut.
And this past 3 weeks, 3 instances of me saying, well, I'll think about it. I should have said no. So, and actually I said yes. I said a qualified yes to something recently. And after sleeping on it, I decided, no, Monday I'm calling them up and saying, you know what? It's a no. So it's kind of hard to limit yourself, especially when you like solving problems. I mean, I know this is, I'll pose it as a question. Do you like solving problems?
I love it.
Right?
Nothing more fun than that.
So it's really, really tempting when somebody comes with a juicy one. But if somebody came to me and said, well, we want you to develop a process for more rapidly painting a car. It's like, I wouldn't know where to start. I'm the wrong guy.
And keep in mind, my realm of experience in problem solving has been a very, very narrow focus. Once I left the environment where it was food processing machines and they were more wide and varied things that we solved, I was narrowed down to a very, very narrow thing, which in one sense was very good. That's why the high precision things I did, I was dumped into a realm where those things were necessary, and I had a pretty decent background in it. So that's I'm not necessarily a super good product development person in the grand scheme of being in a product development company where you have this vast array of things. I'm probably, worthless in a vast majority of those areas until you get to where my expertise lies, and then I'd probably be pretty helpful. So, and even machining, people forget that I have a very, very narrow focus. There's guys doing tons of stuff that are awesome. All the stuff with production and different things. Super, super good guys. I just happen to be in a very narrow realm where I focused 100% of my energy on that. And, if you do that, you're going to get reasonably good at it. And so I am not the, be all end all to problem solving. I just happen to enjoy it. And I'm sure Tom and I will have fun. And both of us I'm sure will be willing to say, I don't have a clue. I don't know where to start,
Well, so my job is going to be to guess which of these problems, are completely inapplicable. Like if somebody wants you to make a better Milano, which is hard to do, that's one thing. We're going to put those problems aside, but I think me and I'll get a couple of consiglieri. We'll figure out. Yeah, this is the one. So, message to everybody: go to pfg.gg/links, and there's a great big honking button right underneath a caricature of Robin and Tom. Hit that button. Describe your problem, and we will review that. I'm hoping we get thousands. Or a dozen. All right, let's gear shift. We're going to gear shift into the next topic because I'm looking at the clock and we're having too much fun already. So I'm going to rant a little bit, and then we'll open this up for discussion. Robin and I talked a little bit before the podcast. In my engineering career, I saw a lot of drawings. Robin's seen a lot of drawings. We've seen a lot of drawings. And it's really funny, it's maybe sad when you get a drawing where the size of the plywood backing is specified to 4 decimal places, where the, or here's a horrible drawing, happens to be one of mine, where it's got 2 dimensions on it and there's no other information. It's like, what are you even doing? This is actually enough information for me to go to the shop to make this, but it's not enough information for me to throw it over the wall to somebody who, let's say, I don't have constant contact with, or we're not on the same wavelength. So the ability to capture some of that information in a drawing is critical. We're really used to kids these days making 3D models in Fusion or Onshape, or pick your 3D modeling software. Usually with respect to getting it into the 3D printer so that we can print it. But can you take the information that they just generated in Fusion and hand it to another maker somewhere else and have them make the part? The answer is probably not. So there's this continuum. On one end of the spectrum is you're the guy going to be making the part. So you could almost, scribble down a couple of numbers on the back of an envelope, run down to the shop and make the thing, and you're done. You didn't need to make a drawing. You didn't need to send anybody information. Moving up the spectrum, Robin was talking about the folks that he works with. They're on the same wavelength. They know what tolerances they work within. They know what materials they're working with. So they could generate a drawing which doesn't meet the requirement of being able to throw it over the wall. Further down the spectrum is, probably at the end of the spectrum, is a fully standards compliant drawing that has all the information that you can hand anybody in the industry and they will successfully make that part. That drawing is not trivial. And Robin, you said that getting to that drawing can be as expensive as doing the engineering to design that part. Is that accurate?
Or more? Yeah.
Yeah.
Well, especially when you consider if these parts are going into an assembly, and you have to make sure that your tolerance stack-ups will allow the things to bolt together. And that is a you mentioned GT&D. That's really not. It's really not that mystical. Way back, I was flying somewhere for the people I worked for. I took the ANSI 14.7 book with me and just sat there and read it cover to cover. Read every description. Read it and none of it is rocket science. It literally is just being familiar with it and go, oh, okay. And once you do that, you're good to go. And there's a bunch of very powerful things in there, like basic dimensions and, minimum material condition, maximum material condition, where you can really get open tolerances up based on the feature sizes. So you give them something where if the hole's on the minimum, it's going to have to be a lot more precise, but there's nothing keeping you from running another drill through that hole to take it to maximum, and then the part will work. So there's things like that are a real benefit from that. But yeah, it's not as difficult as it seems. It's really just a matter of getting used to the symbols and what they mean.
So when you talk about that standards book, is that easy to acquire? Like if somebody listening to this podcast wanted to run out and get
I don't know where you go for it, and I don't know what the latest is. I think it's still considered ANSI 14.7, but there's probably some other digits after that whatever the latest version of it is. But I don't think anything of any substance has changed in it.
Okay. And what I did,
and it's
what I did with that particular project from this client that I currently have is I went online and I found some articles and I decoded the small amount, but I think it's a really good exercise, and I think I'm going to take that as a challenge also to get that and go through the whole thing.
And there are some little nuances like double arrow TIR versus single arrow, and it's a subtle difference, but then when you study it and get it in your head, you say, oh, okay, I can see where that would matter or not matter, and things like that. So there are things that are at first glance like, what? And then you look at it more and say, okay, I see exactly the purpose of that.
So when I was growing up, my dad had this book on the shelf, and he kind of pointed me at it repeatedly, and here it is. It's Engineering Drawing by Thomas E. French. Okay, commonly known. This book is commonly known as French. And it's classy. Isn't that classy? McGraw-Hill. I don't know what year. Let's find out what the year this is. This is 1947. But if you open up this book, just anywhere, it's just, I'm going to turn you off for a second here. It's just art. I mean, it is absolutely gorgeous. Here, I'm just going to randomly open to another spot. Look at that. So, the ability, my dad always hammered into my head, the ability to put something on paper that transmits information to another person is so important. Dad was an electrical engineer and designed radios, and he worked for Sonar Radio Corporation for many years. And he drew schematics, big, of the radios, and they were just works of art. And I learned an awful lot from that. But one of the things, so while I was sitting here this morning fixing to get ready, my elbow was sitting on a drawing, and here it is. This is a connector that I use in some of my RF stuff. This is called a 716 panel receptacle for high power RF stuff. Now, the interesting thing is, some of us look at the 716 and we say, oh, that's 7/16 of an inch. No, that's 7 millimeters and 16 millimeters. It has to do with the size of the coaxial connector. But if we look at this thing, it's pretty interesting. It's got dimensions. I got to cover up my eyeballs. It's got dimensions in the right places. It has the nomenclature that's very clear. It has double units. It has millimeters and inches, uh, and it looks pretty. It looks pretty good. But one of the things I want to bring up is this whole concept of design intent. So, you could dimension something, and you could tell me, Robin, if you think GD&T has anything to say on this, but you could dimension something from, for example, on this connector. You'll note that this flange is all dimensioned. It seems to be all dimensioned off of this corner here, where and not off the center of the connector. Well, you could make the argument that, gee, maybe they should be dimensioning that off the center of the connector. So not only do you need all the data, but you need the data in a way that transmits what's important. And you can have a drawing that's got lots of dimensions, but you still don't understand what's important. Is that something that you've seen examples of, both plus and minus?
Yes. But the that comes into play with how you dimension that. You can dimension it in multiple ways using GT&D. And with that example you just gave, whether you use the corner or the center, well, then that comes into play with, well, who's using this drawing? Are you going to drive them nuts by having it in the center such that they can't put it in a simple fixture where they rest it on two sides and check other dimensions relative to the corner that everything was derived from, where they have to, pick a center and use a CMM or whatever to pick it up, or a fixture to pick the center up? It's the same way as a non-machinist dimensioning a drawing. There are drawings that you'll get where you say to yourself, this guy must have been a machinist, because every dimension he has is from the end that he knows I'm going to be machining it from.
Right.
And Z0 is on the end of the part, and he put every single axial dimension off that end that is possible. And when there's an operation from the opposite side, he dimensioned those dimensions from the opposite side. And that's drawing can be correct, and it can be very machinist friendly or not. And those are all things that, those are tough to get across. And I guess that's really what the push for simultaneous engineering was to, instead of having the designer make the drawing, throw it over the wall to the machinist, they sat there together. And just like the things that Adam's been doing with the machinability aspects, the videos he's been doing on the on all those stupid things to do on how you design a part, all those things happened before the drawing was completed. The machinists were there saying, well, you just made that thing really hard to make there. Can you do this? And oh yeah, we'll do that. So instead of having that be two separate things that took weeks of back and forth, simultaneous engineering says, let's hash this out together right from the start. And the more that happens, the more the engineer becomes educated, thinking like a machinist or production person, and everything goes better. But most of us are simultaneous engineering because we are the designer and drawing person and machinist.
When did that term arrive on the scene, simultaneous engineering?
Pretty old.
Okay.
I'm guessing maybe 10 years ago.
Okay.
But it became a big thing. Like, companies were saying, hey, this simultaneous engineering can save us a bunch of stuff instead of this throw it over the wall. And I think that's where throw it over the wall actually became my memory's not all that great on that, but I think could be where that term comes from, because you're pointing out the fact that there's isolation there, and throwing something over the wall and just having it land there and say, okay, what does this mean? If you had done it together to begin with, collaborated with it on making this thing, it would have been a lot better. So I haven't seen it in publications lately because it was pretty far back, but I think a lot of places are implementing that as standard practice.
So I'm working with a subcontractor. So there's a part that I'm working on now, or a system that I'm working on now, where I was originally going to make all the parts. I was going to machine all the parts. And then as I'm coming down to the wire, it's like, you know what, this makes no sense for me to make these parts. And so I'm going to be farming it out. And one of the guys, I can't get into who or what the project is, but one of the names you'd recognize, and I'm heaving it over the wall to him, and I'm like, look, I'm going to give you a rough drawing because there's some details to go, and give me a rough quote. Like, I'm not going to hold you to it, but get me in the ballpark to see if it makes sense. And then you and I are going to, like you said, sit down at the table and make sure there's a mind meld, and that I'm not doing anything stupid. And then we could pass along the model. Another thing I noted, I actually had an epiphany this morning. I have a lot of epiphanies. I think it's the vitamins. At the bottom of this drawing, and this is not unusual, there's a note which we see a lot of. It says, "Do not scale drawing." Okay? And for, I've been doing this stuff for, I don't know, 30 years, and I always thought I knew what that meant. And then this morning, I realized I didn't know what it meant. So what I always thought it meant was, well, this drawing is obviously not drawn to scale. That connector is not that big. So this drawing has a scale of, I don't know, 2:1. And I always saw the do not scale drawing. I never thought about it. Well, this morning, I'm thinking about it, because we're going to be doing this. And I said, well, why is it important that I don't scale the drawing? Like, if I put it in my printer and I tell it to blow it up, should I not do that? And then it hits me that the word scale is a verb, and it didn't mean do not stretch or compress the drawing. That's that meaning of the verb. It meant do not take one of these and measure a feature on the drawing that doesn't have a dimension and use that measurement for anything. That's what it means. Do not scale the drawing. So I opened up French. And if you'll turn your hymnals to page 19, use of the scale. Here it is. And the thing that a lot of people call a ruler, okay, is not a ruler. It's a scale. And what that message said to me this morning was, do not scale. Yes, Robin, you in the back.
I could be wrong on this, but it's only a scale if it is not graduated in actual dimensions. So when you take a rule, the reason the rule is a rule is because it is not a scale. It is actually the dimensions that are printed on there.
Okay.
But then, and some of this comes from casting people, there are shrink scales,
Yep.
which are a ruler, but has been stretched for whatever the shrinkage rate is in the material. And then in engineering or architectural, you have scales for 1/4 inch per foot, on and on and on. But yeah, that's, and you're right. The thing, don't scale the drawing, means don't measure the drawing and think necessarily that everything that is down in ink is going to be correct.
Now, in the olden days, if I understand it correctly, and you were drawing on, the big sheets on vellum, and you were drawing it with pencils, that you actually could scale the drawing. You could walk up to a drawing and measure something, and that would be a reasonable measurement. So
yes, it was intent. But what about that drawing that you just had that might have a tabulated list for variations of that connector, and then meaning that it may be just a graphic representation as opposed to an actual production drawing of that connector.
Right.
So it's therefore passing on general information to a customer for usability, but not necessarily actually accurate in what's drawn there.
Well, there you go. So I was 0 days old when I learned, or I should say, I was this many days old when I learned what do not scale drawing meant. And I've read it 1,000 times. So when I got to school, continuing my story, of course, one of the first things I did is I discovered the bookstore. Yes, kids, there were bookstores. And I went to the college bookstore and I bought myself a copy of French. And this is the copy of French, which looks a lot different than the other copy of French. But there he is. He's given his credit there, Thomas E. French, and of course two new young bucks. And I said, well, of course, this is going to have all sorts of fancy modern stuff. Remember, this is 1979. And, you open this book to a random page. And let's see. Yep. I want to get you a better one here. Hang on. Yeah, here we go. You open the book to a random page, and there's the drawings from 1947. So the message here is pretty clear, is, the art of making a drawing is the same as the art of making a drawing was back then. The difference is you just have to hit that button on Fusion that says drawing, and then you have your tools to make a drawing. You still have to make a good drawing. So if you could make a drawing that you could hand to Robin without saying anything, and then get a part back that's exactly what you wanted, you've arrived, and that's pretty cool. Yeah, there's
one powerful technique that in my career used when the do not scale drawing was I violated that hundreds of times, because I would get we would propose a spindle to or an in-feed mechanism or whatever to a customer, and conceptually, and they would say, yeah, we love it, let's build one. And then I would get drawings from the customer for the piece of equipment where the original one mounted and all that. Well, a lot of those things aren't dimensioned for every single detail. So a technique to use, you never assume that the scale on the drawing is correct, but pick a long dimension on the part, measure it with a scale very accurately, divide that by what the dimension is, come up with the actual scale factor of that printed piece of paper, use that multiplier, and then very accurately measure all the dimensions that aren't there. And I built many, many, many items with a lot of the dimensions that were generated that way in order to not have to go do a visit to measure the machine.
The do not scale drawing should read more accurately. Do not blame me if you scale the drawing. That's what I should say. Yeah. So on modern drawings, there's one other feature I want to show here, and then I think we can take questions. That's a hint for the audience. There's a little a window here that says the CAD file. There's the name of the CAD file right there. So you could make a drawing and still have it point back to your file, but you can deliver this, and you can deliver this as a PDF or, believe it or not, as a piece of dead tree to somebody, and you could still refer back to the ultimate source of information, which is the drawing. Anyway, you can go on, forever on this, but here's my message. If you use Fusion 360, if you use SolidWorks, if you use, pick your poison, I think I just covered 99% of the people who are going to hear this, and you are not currently making drawings, hit that drawing button in Fusion, okay? Get away from the 3D model and learn how to make a drawing. It's a very important tool. And I think the most important thing you have to think of, if you're not hitting standards like these GD&T and ANSI standards, can I make this drawing tell the person that has to make the part how to make the part? Okay, or what's important in the making of the part. In your work, Robin, in spindles, isn't things like the circularity of the cylinder, or the cylindricity of the cylinder, could be more important than the absolute diameter of the cylinder. Is that an accurate statement?
Yes. Yeah. And some of those things are by default. If you have a 50 millionths total tolerance on a diameter, you inherently are going to be less than 50 millionths cylindricity. As long as you're paying attention, because you can't just pick where you're going to measure it and get the right size.
Right. So I don't think we have time today to dive deep, but I do have one comment. Yes.
The biggest reason to make a drawing is that the 3D model does not have any tolerancing whatsoever. So in that regard alone, you can't send a print unless you're just sending it to a print factory and saying, yeah, just print this. This is the file, print it, and you get what you get. And I mean, obviously they would need to have it be that it was roughly in giving you the sizes that the original thing was.
Mm-hmm.
Yeah, you've got nothing. So it's virtually impossible to send something out in a 3D model,
right?
Only unless it's the 3D world, and even then you're going to have to specify some tolerance of it being, within some realm of being the correct scale to the 3D model.
I totally agree. Dale says, and learn how the note button works and use words to get design intent on paper. It can also help you remember what you were trying to do down the road when you go back to it. And Dale also says, in SolidWorks, you can tolerance the model, but only if you open it with SolidWorks. So
agreed.
Know your tools and know how to use your tools. So there you go. Make a drawing and hand it to somebody else. And if they can't understand it, go redo your drawing. Well, thanks, Robin. This was fun. I hope everybody goes out and gets a copy of French. And if you're able to find a copy of an old version of French, I think it's worth buying just to look at the gorgeous work in here. It's just truly amazing. With that, I think I'm going to say thank you very much, Robin. Are you going to be in the after party roundtable?
For half an hour.
For exactly 1/2 hour. We have Milanos over there, so we'll see you. We'll see you there. I don't know if that's a positive or negative. I don't know if Robin ever wants to see another Milano again, but I know I do. Well, we're going to wrap it. Timing is excellent. We didn't go over much, but we hit all the high points. Hey, next week we'll be back. I don't think I see any impediments to that. It is October 6th, so next week is what, the 13th? Yeah, so that should all work out really well. Anyway, have an awesome week. Get flat, stay flat, and we'll see you guys on the other side. Take care.